Okay, so I will be recording today so that you can go back if you need to make sure that you're able to understand. If you need to fast forward or rewind this video, if you would like to begin working on the homework, I'm also doing it for that reason as well. If you're understanding it so that you don't necessarily have to go through the whole thing. So I'm going to make it like a video lecture, not necessarily embedded with questions like an ed puzzle would be, but just so that you can get the gist of it because, you know, time is ticking and we have finals not too far away, pretty much a week and a half from now. So that's why I'm doing it in this format. So here we go. So projectile practice. First of all, we have two equations. We have equations that involved the parameters x and y, and we had something like the magnitude, and it was like the cosine of the angle, and it was multiplied with t. Then it was also the magnitude, and it was like the magnitude of the velocity, if you will, with the sine of theta, and it was multiplied with t. Now, this is a parentheses, but I mean, they're all multiplication, so it's all one big old chunk. And then here at the very end, we're going to be subtracting a 16t squared. Now, 16, in this case, we're going to use 16 because of the fact that we're talking about feet. The other one that we were looking at before was, it would have been the same thing. The only difference was instead of 16, you would have had a 4.9 t squared. Okay? So if you have something that is 4.9 t squared, it's because you're talking about something that's in meters. So we were talking about gravity last time, and you have two different equations that you could use for the y. So everything is still the same. Like, let me highlight it in orange, if you will. All this is still going to be the same, and it's still going to be subtracting, and it's t squared. The only difference is if it's feet per second, or feet, that is, it's going to be 16. And if it is meters per second, it would be 4.9. Okay, so we have this problem that is dealing with feet, so that's where we're going to use this one that is 16. So our components are going to be, or parameters, parametric equations will be x is equal to 40 times the cosine of the angle 30 degrees, and it's multiplied with t. Okay? And then the other one would be 40 times the sine, because we're looking at that y value of 30 degrees, and this is also multiplied with t, and we're going to be subtracting a 16t squared. Again, 16 because we're dealing with feet. So let's read the question. I kind of jumped the gun a little bit and see why we wrote these parametric equations. It says, some kids wanted to try and kick a soccer ball over the fence. So here's your fence, if you will, right here, into the neighbor's yard. The fence is 20 feet away. So the point of contact from the soccer ball to the fence is 20 feet. And the fence from right here, ground level, to the top of it is going to be 6 feet high. So Wanda uses a kick with an initial velocity. So this initial velocity is your magnitude. We go ahead and highlight that in green. Oops. It's that magnitude of the velocity, which is 40. That's where we got the 40 here. And the angle of 30 degrees. Now you might see angle of elevation or angle of inclination. Basically, that it's inclined. It's this angle here, if you will. Okay. So there's 30 degrees. So it says write the equations to model the path of the ball. Okay, so we just wrote the two parametric equations, and now we're going to go to B, where it says, after how many seconds is the soccer ball 20 feet away horizontally? Okay, so if we wanted to see after how many seconds is the soccer ball 20 feet away, we're trying to see how long does it take for it to complete this x distance traveled of horizontally. How many seconds would it take for it to cover this 20 feet? Now, we're not being asked right now how high would it be at that point in time. We're just being asked, find the t that makes it complete that 20. So this 20 feet that's going to be traveled is the x value traveled. Okay, so that's the x value here. Ultimately, this is the amount of feet covered, and then the rest of the equation is just as you would normally see it. Okay, so it's 30 degrees, and then it would be t. So our goal is just to divide. So that t is equal to 20 divided by that. So 20 divided by this entire product, and then we would end up getting the t value. So let me go ahead and pull up the calculator. Okay, so pulling up the calculator, we have, first of all, I'm going to go home and press 5 and then press 2, and I'm going to change this radian to degrees because we are in degree mode, and I'm going to make it my default and press OK. Okay, and then I'm going to get a new document by pressing 1 and then no for unsaved changes, and then get that calculator page going. Now you could do this, or you could do Scratchpad. I suggest that you do this because there's other things that we'll learn how to use the pages talking to each other, like the graphing calculator part and this part right here that we just opened. Now what we're trying to do is we're going to put this right here into the calculator. The reason why I just showed you that as far as changing the mode is, please remind yourself that you are basically fighting against my AP Calc classes, which are strictly in radian mode. Right now you're pretty much strictly in degree mode, so you want to make sure that even though you're setting up the work correctly, if you're not in the right mode, you're going to get the wrong answer. So let's go ahead and put this in the calculator. So we'll put 20 over 40, so control divide, 20 over 40 times the cosine of 30 degrees. Okay, and I'm going to press control enter so that I get the decimal equivalent. So after how many seconds is the soccer ball 20 feet away? You're going to put 0.577. So t is about 0.577 seconds. So it's saying after that amount of time you'll be 20 feet away from the initial point of contact. So at this particular point, how high is the soccer ball? So this is the word application, what we talked about last time. All you're going to do is, now that you've solved for this t, you're now going to plug in that t known value into the y parametric equation so that you can see, well, how high is it at that point in time. Okay, so it will be y is equal to 40 sine of 30 degrees, and then it's multiplied, this whole thing afterwards, by that 0.577. Okay, now it's probably good to show you right now is that I don't want to use a rounded answer right now. I want to use as exact as I can from my equation that I had over here. So I would suggest about 5, maybe 6 decimals. If not, just grab that one that you have by going up, and then you can get it exactly. And in this case, it's root 3 over 3. Okay, so I didn't press control enter that time. I just went up to grab it and press enter so that I could see what is it exactly. So you could do that and get root 3 over 3, or you can just copy and paste that entire thing as you're putting it into the calculator, and I'll show you how to do that here real quick. So 40 sine of 30, so here we go, 40 times the sine of 30 degrees, close, times, now this is what I was talking about, you can either go up and grab that or type it in, or go up and grab that and press enter, and it's already multiplied. And then we will subtract these 16 times the same thing squared. So it's minus 16 times, again I'm going to go up there and grab it, just showing you how to do that, and I'm going to raise it to the power of 2. Okay, so again I'm going to use control enter just so I could get a decimal answer, and I get about 6.214. Okay, 6.214, and I'm rounding the answer at the end. I'm not rounding in between the pieces in between for each individual answer. Again, that's the reason why I'm showing you this video, so you can get the exact. So if you don't want to use a calculator to get the exact, I would say on your paper write at least 6 decimal places as you're going through the problem. And then at the very end you could just round it to 3 decimal places, and it should be fairly close. So 0.214 in this case, 6.214, and that will be feet. Always, always, always remember your units. So approximately 6.214 feet. Okay, another way that I could show feet, just FYI, is if I put, it looks like an apostrophe. Okay, and if I wanted to show inches, so that is feet, just for notes purposes, And if I wanted to do inches for future purposes, it would be 2, basically a quotation mark. Alright, does the soccer ball clear the fence? And explain. So at this point in time, t is equal to 0.577. It is 6.214 feet. It of course will clear because the fence is only 6 feet. And at this point in time, it's going to be 6.214 feet high. So yes, the soccer ball does clear. Ball clears as at t is equal to 0.577. Basically, when it's traveled that 20 feet that's needed here to get to the fence at that point in time, the y, or the height, is 6.214 feet, which is of course greater than the 6 feet required. Alright, so our next example. Okay, so we have a shooter on a rifle range, and it says from a height of 1.83 meters, a marksman fires his gun at a target which is 152. So here's the target, 152.44 meters away. So already meters should be telling you I'm going to use that 4.9 t squared in my equation, okay? And that's that magnitude sine of theta times t is equal to y, okay? So from a height of 1.83, what's different about this is that we're not shooting from down here at ground level. We're shooting from a height that's already above ground level. And I'm going to show you how to do that here in just a bit to set it up. So the bullet leaves the gun at the amazing speed of, so there's my magnitude of the velocity, and at a slight angle of 1 degree. So it's saying if it shoots straight, this little angle that it's pointing up is going to be 1 degree of angle of elevation from the horizontal, if you will. So from being parallel with the deck, it's just 1 degree up from being parallel with the ground. So write the equations to model the path. Well, we know that, again, x is still the magnitude, which is 670, the cosine of the angle, and let me put parentheses there, it is multiplied with t. I'm going to do t as lowercase now because that's, I guess, the kosher way that you should do it. It's not a big deal, though, if you don't. And then magnitude times the sine of 1 degree, which is multiplied with that t minus 4.9 t squared, again, because we are in meters per second, and that's that 4.9 rather than the other one, 16, that we did on the other example. Alright, so the last thing that I need to do is that I need to add 1.83. The reason why I'm adding 1.83, think of this as your initial value, almost like a y-intercept. Long ago when you did y equals mx plus b. B was the initial starting point, and then from there you would go a certain slope away. So this is almost like an initial starting point to where initially it needs the 1.83 first. Then the height after that will either go up or down, depending on if the bullet is on the rise or on the fall as it's approaching the target. Okay, so that 1.83 has to go on that initial y parametric equation. After how many seconds will the bullet reach the target? So reading that, intuition says you're talking about the x distance, because that's what it's going to reach the target. Necessarily not hit it, but reach it. Okay, reaching it meaning from this vertical line all the way to this vertical line. Okay, so this is going to be when x is equal to the distance of 152.44. Okay, so 152.44 meters. We're trying to solve for t. So 152.44 is equal to 670 cosine of 1 degree, and then we're going to divide because we're trying to get t. So of course t is equal to 152.44, and see, you can fast forward or you can jump ahead if you want, if you're understanding this and don't need to see the work. Alright, and then when you divide by this, it should give you the time, so we'll do that really quickly. Okay, so 152.44, control divide, and it's going to be divided by the 670 and then the cosine, so 670 times the cosine of 1. Again, I am still in degree mode, so I'm good to go. And I'll press Control Enter, and then the answer comes out to about 0.227 or 0.228. So t is approximately 0.228 seconds. That's the time that it takes to reach the target. So that's pretty fast. Being that it's 152 meters away, it's a fraction of a second. It's almost like 1/4 of a second. Okay, so when it reaches the target, how high will the bullet be? So again, I know that t is now that 0.228, but I'm not going to use my rounded answer. I'm going to use the exact answer, which if I go back to the calculator, it's this right here, okay? Which if I press enter, in this case, it didn't give me a √3/3 or anything like that. So if I wanted to, like I was saying before, if I wanted to use a decimal equivalent, you see this has 6 decimal places. I can use 0.227557. So 0.227557. If you wanted to, and you don't want to use the exact by grabbing it in the calculator all the time, you can write down to 6. I would say a minimum of 6 decimals, so that at the very end, your rounded to 3 decimal answer is as accurate as possible. Okay, so how high will the bullet be? So let's go ahead and put this into the y equation. So I'm going to put this here for t and here for t. So let me go ahead and solve this out. 670 times the sine, because we're dealing with the y value, of 1 degree, times, now I'm going to go ahead and use this 0.227557 because it's 6 decimals. Well, actually, look at that. There's a lot more decimals when I grab it like that. But I'm only going to use the 6. You know what? For the sake of time, I will just go up and use this exact. Alright, so minus 4.9 t squared. So minus 4.9, again because it's meters, times t squared. And then at the very, very end, we're going to add that 1.83 that we were talking about from before. That's that initial y value. And when I press enter, the answer comes out to about 4.237. So 4.237 is as high as it will be at that point in time. 4.237 meters off the ground. Okay? If the same shot was fired across an empty field, how long would it take for the bullet to hit the ground? So it's basically saying when the bullet hits the ground, y is going to be equal to 0. Because if the bullet only returns back to where it came from, ultimately, so if it has this parabola and it stopped here at the initial height, it would be 1.83. Almost like you could consider that 1.83 as the height if you were trying to find like 2 x-intercepts over here. So this almost looks like it's crossing an x-intercept if and only if I create this to be my x-axis and this could be my y-axis. Oh, actually it would be right here. Okay, but that's not the case here. But you can see how there are 2 zeros of the function there. What I'm trying to essentially solve is whenever it's actually equal to 0. So I don't want it to equal 1.83 the way it did right here. I want it to go further down until it equals a height of 0. Okay, so that's why y is going to be set equal to 0. So to solve for 0, we're going to say 0 is equal to 670. So it's like we're going a little bit backwards. The way we solved the other one for t and then plugged it into the y equation, we're going to solve for t, but then we're going to plug it into the x equation because we want to see how far across an empty field. What's the horizontal distance that it will end up traveling? Okay, so t is going to be unknown, so I'll leave it as an unknown variable. And then we'll keep going by saying minus 4.9 t squared. And it will be plus 1.83. We're trying to see when would this equal. Now, a little recap, or if you've never seen this before, I'm going to show you a quick way on how to find this with our cool calculators. Let me rewrite this so it's a little bit easier to read. I'm going to solve for this equation here. And I'm going to solve for the variable t. So this is how I'm going to put it in my calculator. I'm going to put solve and then all that, and it should spit out the answer for me, okay? So let's go ahead and go to the calculator right now. I will press menu, 3 for algebra, 1 for solve. And then I'm going to press solve when 0 is equal to, and then I'm going to put all that stuff that I wrote. 670 sine of 1. So 670 times the sine of 1 degree times our variable t. Now you can use x if you want, but I'll just show you that this keyboard will allow you to still solve for other variables. And then it will be minus 4.9 t squared. So minus 4.9 t squared, and then plus the 1.83. And then at the very end, comma, your variable that you're looking for. Okay? And then close, and then you should see that you'll get an answer. Now we have two answers here. We have negative 0.147. We have 2.533. Okay, so if I go over here and I put t is equal to negative 0.1474, if you will, or if let me do the 3 decimals. So 147, and then 2.534, and 2.534. So those are two answers, but the one that I'm concerned with using is just this one because we cannot have negative time. Okay? So again, I'm going to use as exact as I can. So let me go back to my calculator, and I'm going to use this 2.53375 answer, which comes out to 2.533747. 533,747. And the way I got all the rest of those decimals is I just went up. So let me do that again. Let me just press enter on that. I went up to my answer that I got way up here, and then I pressed enter, and then right here it showed you the 6 decimal places that I'm needing throughout the problem. Okay, so that's what I'll write. 533,747. 533,747. This is the time that I'm going to do. Okay, so plugging this now into the x right here will show me how far did it end up traveling across the empty field. Okay, so this is what I'm looking for. This is the time I'll use, and I'm going to plug it right here. Okay, so 670 cosine of 1. Let me go back. Here we go. 670 times the cosine of 1 degree, and then we're going to multiply it with that value that we got, 2.533747. 2.533747, and then we get an approximate answer of about, let me see, make sure that I did this correctly, about 1,697.35 meters. Okay, so we could say, let me see if this gives me to 3 decimals, and yes it does. So 1697.352. 1697, whoops, 1697.352. Let me make sure that is what I got. 0.352, yep. And this would be the x, and this is in meters across the field. So it's like you're going back and forth between what are you going to set equal to 0, or what are you going to set equal to a certain number, so that you can solve for the t in any one of these parameters or parametric equations. Then you use that t to put it into the other one to solve what is the x distance at that point, or what is the y distance at that point. Alright, so now what we're going to do is we're going to look at parametric equations and circles. Okay, so if I put my T-min, T-max, and set them equal to that, you can do this, but this is more so talking about the TI-84 pluses from before. So what we're going to do, we're just going to put this straight into the calculator and see what kind of picture we get. Alright, so let me go here and press Control, add a page. I'm going to add a graphing calculator page. Okay, and then mode, I'm going to press menu, and then I'm going to put it to, I believe it was, oops, not that one. It's going to be menu graph entry and then we're going to enter it as a parametric equation. Okay, so if you wanted to do it here as far as what it showed for your T-min, your T-max, you can if you want. The T-min in this case would be 0 and 360. So we'll say 0 to, whoops, 360. And the T-step, I believe it was 5. Okay, so we'll go down. We'll go and make a T-step of 5. The smaller the number, the more exact the picture will look, or the smaller the step, because it's taking data from smaller incremental steps. So 2 cosine of t is the x parametric equation, 2 times the cosine of t, and then 2 times the sine, I believe, 2 times the sine of t is the other one. And when I press enter, you see this picture here. Now you see it a little jagged. It almost looks like a polygon with a bunch of sides, not necessarily a perfect circle. The reason of it being is, I just want to remind you, is the window that we had, the actual step. So let me go tab, and let me go up, and I'll change the step so that it's more exact, if you will. So 1. And you can see that it gets a little bit finer as far as a circle. And if I were to change it up just for instructional purposes, let's say that I want to see it defaulted it to 1.8. Let's say that I changed it to 10 instead of the 5 that it originally became. You can see that they have more edges defined. Okay, so that's just what's going on there. I'll put it back at 5 because that's what the paper was showing. And there's your circle. Now this circle looks like it has a radius of 2, and it also looks like it has a center at 0, 0. So I'm going to go ahead and draw that right now. So here's that. Let's say that this is, each of these is 2, so I'm going to draw a quick circle for you. So 2 is about here. It's a little bit off. I'll move it over. There it is. Okay, so with a radius of 2, let me just redo that. So with the radius of 2, so left 2, up 2, ultimately it would look something like that. Okay? And then this one, if I were to do this in the calculator, for the sake of time, I will not. 1, 2, 3, 4, 5. 1, 2, 3. So watch what I'm doing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. With this creating a circle tool that I have, it will allow me to do the following. Okay, so pretty much there's your circle. 2, 3, 4, which would result 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pretty much something close to that. Okay. So now, real quick, the center is 0, 0. The radius is 2. Over here, the center would be 0, 0 also, and the radius this time would be 5. Now you should start to identify the pattern. X-wise, I'm going to move a horizontal distance of 2. So it's like that is 2. And then y-wise, I would do a vertical distance of 2. Here it would be 5, and then here it would be 4. Or sorry, 5. What did I say? 4. But anyway, because of the fact that those numbers are the same, that's why you're going to have, the magnitudes are the same, you're going to have a circle. So over here, the radius would be 8, and then the center, because there's nothing over here, and you're going to see here in just a bit, would still be 0, 0. Okay, so we'll come over here, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's see if we can draw this fairly accurate. I will start here and come all the way down until they are satisfied with the 8 and 8 approximately radii. Okay, so again, let's do it by picture. X, Y, there's that X, and then y-wise, there's that 8 value. Okay, so now that you know that, let's go to let's go and see what it would be if there were other numbers added and whatnot. So this one I will put into the calculator. So 5 plus cosine 4 cosine of t. Let me go back to pressing tab, and I'm going to alter my original one. And I have 5 plus 4 times the cosine of t. And for my y parametric equation, I have the following. Just 4 times the sine, of course, y is sine, x is cosine, and I get this. Okay, so my center no longer is that 0, 0. In fact, this one, if you were to eyeball it, 1, 2, 3, 4, 5, this looks to be the center over here. Okay? So the center actually is going to become 5, 0 because of the fact here I have a number outside of this product piece. It's like, if I could rewrite it, 4 cosine of t plus 5. And over here it's 4 sine of t plus 0. It isn't necessary that I write this, but I'm only writing it to show you that the centers of this circle would be 5, 0. So we come over here. 1, 2, 3, 4, 5. There's the center. And then from there I'm going to go out x-wise 4. So 1, 2, let's go to the left. 1, 2, 3, 4. Here's the edge x-wise. 1, 2, 3, 4. There's the other edge. And then up and down I'm going to also go 4 because that was the magnitude of that coefficient for y. So let me get a red. I'm going to go 1, 2, 3, 4. And then 1, 2, 3, 4. This is a little bit hard to read or hard to see because it didn't copy as well as I'd like. But ultimately it's going to come out to a circle that looks something close to this right here. Okay, so where the radii are still 4, because those are those magnitudes in front of the cosine and sine piece, and then the center is 5, 0 in this case. Okay, so here's 4, and then here's 4. And then yes, the same thing would apply over here. The center here would be 5, negative 3, exactly what you see. The center over here would be negative 6, 2. So I would identify 1, 2, 3, 4, 5, 1, 2, 3. So here's the center. And then I'm going to go left and right because that's cosine or x. I would go 4. 1, 2, 3, 4 to the right, 4 to the left, and then 4 up and down. So 1, 2, 3, 4, then 1, 2, 3, 4. Approximately this is where the circle would fit. And I have something that looks like the following. Okay, and then the last one, real quick, would be 1, 2, 3, 4, 5, 6, and negative 2. Here's the center. From there, I'm going to, again, go 4 in all directions. So 1, 2, 3, 4, 1, 2, 3, 4 approximately. And going in all directions, my picture looks something close to the following that you see. Okay, and let's go to the next part. It says, in this form, what does A represent? So A is here the coefficients in front of the sine or the cosine that we were discussing earlier. It's basically representing the radius. So A is the radius. And what does H and K represent? Well, H and K over here are the numbers all by themselves, and H and K are the center of the circle. Label these constants. If I had it looking over here, this would be A, and that's like the distance. That's just the radius, and you can see that just protruding from the center. And then HK would be the center itself. HK is the coordinate point center itself. Okay? So now let's come over here and we're going to write from what we see. Well, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We know R is 5. The center is negative 4, 3. So let's write the x one first. The x one we know is going to have cosine of t, okay? And the reason why we're going to go ahead and write 5 in front of that is because of the fact that that's the radius. So let me go ahead and rewrite it like starting with the 5 cosine of t, just like we did over here from the other ones. And then 5 sine of t, because the radii are the same. They won't always be, and we're going to do things within the ellipse here in just a bit, and you'll see what that looks like. But 5 cosine of t, 5 sine of t, and then we're going to add at the very end the minus 4 and then the plus 3, because that is what you see as far as being the center of that circle. Okay? And again, you could rewrite it the other way if you wanted to write it with the negative 4 first plus the 5. Doesn't matter, it's still going to be the same. And y is equal to positive 3 plus the 5 sine of t. Ultimately, it's still going to be the same regardless. So real quick, I'll do these. 1, 2, 3. 1, 2, 3. So the radius is 3. The center is 3, negative 3. So ultimately, x is equal to 3 cosine of t plus 3. And y is equal to 3 sine of t minus 3, because that y and the x correspond with the center. 1, 2, 3, 4, 5, 6, 7. So we have from negative 2 all the way to 5 is going to be 7. And from negative 1 all the way to 6 is going to be 7. So r is 7. And the center looks to be negative 2, negative 1. So x is going to be 7 cosine of t minus 2. And y is going to be 7 sine of t minus 1.